apply electricity, we are going to be dealing with exam-based questions that are involving current evaluation. So we are given this first question to find the power and energy for an inductor. This is the inductor. We have 0.1 Henry. Then they said whose current and voltage are given by this interval. So we have the current and voltage in range. So we are going to be calculating also the power and the energy in range. So these are the conditions, these are the ranges that they gave us. T less than 0, t greater than or equals to 0, less than or equals to 1, then 1 t greater than 1. We also have the same thing here too. So now we know the formula for power. To calculate power, it is I of t multiplied by V of t, and we have them in 3 segments. So you just also you answer it in 3 segments too. So you just say P of t also will be, you answer for t less than 0, you answer for 0 less than t greater than or equals to 0, less than or equals to 1, and you answer for t greater than 1. So yes, since we have I multiplied by V, so we take this, 0 multiplied by 0 is what? Is 0. Remember, power is in watts. So then 20t multiplied by 2, that will be 40t. We have 40t here. Then 20 multiplied by 0, that's also 0. So that's all for the power. We can move to the energy. Now, the energy, you can say energy is the integration of power. Yes, it is correct, but you have to use what they give in the question, which is the inductor. So doing that, we're going to be using energy. E is equals to Li squared, since we have inductor. So E is equals to half, we are going to be using it equals to half Li squared. So where L is our inductor and I is our current. So we'll do for each range. For t less than 0, for this range now, it will be E is equals to half open bracket 0.1, the inductor, then the current here is 0 raised to power 2, that will give us 0J. Then for the next range, for this range now, it will be E is equals to half 0.1, then the current here is 20t. So note that this square is for the 20 and it's for the t. So we get 20 square, which is 400, multiplied by 0.1 divided by 2. We get 20. So with that t square, that will be 20 t square j. So for the last range, 1 less than t, we're using also the same formula, half into 0.1, then the current here is what? 20. So when you calculate that also, you have 20 joules on your calculator. 20 joules. So and then you can put it in the form, in this form. So E is equals to, you open your bracket, 0 20t square, then 20, and you write the ranges there. T less than 0, and 0 this here, and this here. So that is the range. Without wasting much of our time, I'm going to be going to the second question. Now observe the question displayed. In the circuit below, the switch is closed at t equals to 0. This switch is closed. So determine the currents IS. This is IS here, and here is I1 and here is I2. Let me indicate that. You have I1 here and I2 here. So we start by short circuiting this capacitor. When we short circuit this capacitor here, we notice that this I1 and I2 will sum up to come and become this IS, right? So we start by writing that at t, according to what they gave in the equation, at t equals to 0, the switch is closed. So what do? We short circuit the capacitor. So that means there will be nothing here again. So and if there is nothing there, it means that IS is equal to I1 plus I2. So having known that, we are going to open circuit the same capacitor again. When we open circuit the capacitor, we can get our I1. So let us open circuit it. Let me write open circuit. Circuit the capacitor. So by doing that, when we open circuit, that means there's no current flowing here. There's only I1 that is valid in this place. So we can get our I1. And what is I? I is going to be V over R. That means that current there. I can say R1. So that will be 100 over 50, which is 2 ampere. Now, I need I2 also. I've gotten I1 now. I need I2. So because I want to add I1 and I2 to get IS. Remember, they asked us to look for IS in the equation. Are we together? So now, we are going to take the time constant for this I2. We are going to take the time constant. And the reason why we are taking time is that we are going to be using this formula. This formula, I is equals to V naught over R exponential minus T over tau. So this is the time constant that we need for the second voltage current here. So we need to get the time constant. And what is time constant for involving capacitor is going to be the resistance multiplied by the capacitor. So now resistance in this case is 300 and the capacitor is what? 300 microfarad. Microfarad is times 10 raised to the power minus 6. So in that way we can solve. We can just write 300 multiplied by 300 times 10 raised to the power minus 6. So let's see what that gives us. When you place that on your calculator, you are going to be having 0.09 seconds. So 0.09 seconds. So now this is the tau. Now we can solve for this. If we come here and see, our V naught is the voltage. That will be 100 divided by the resistance, second resistance. That's 300 multiplied by exponential raised to power minus 9. So for the I2 we have the current, which is 100, then the R2, which is 300 here, multiplied by the exponential of this time is the one they gave us in the equation, and it is 2.5 milliseconds. We convert that to seconds, that's times 10 raised to power minus 3. So you'll be having, do that on your calculator, you'll be having 0.0025. So that is minus 0.0025 over tau. Your tau is 0.09 seconds because you have converted that to seconds to the other time. So both must be in seconds. Don't use one in milliseconds and then use the 9 seconds. So now, calculating for that value on our calculator, you calculate that, you are going to be getting 0.3242. 0.3242 ampere. Now we cannot get our total supply of voltage current rather. So that will be I1 plus I2. So what's our I1? Our I1 is 2 here plus then this 0.3242 in amperes. So that is 2.3242 ampere for our IS. So which is the current that we asked to look. I was drawn from the supply after this time. So that is all for this video. This is the answer for the question. Like, share, comment and subscribe. More of these videos are going to be coming, especially exam based questions. So thank you very much.